Hello everyone. In this Arduino Project 1 video, we shall explore the pulse width modulation basics and the concept of duty cycle. We shall also explore some use cases for PWM applications. Also, I am going to control LED brightness using PWM generated from Arduino Uno pin 9. I am going to share the results of LED brightness control and shall discuss the C source code step by step. In a previous tutorial, I have already demonstrated how to use MSP430 timers for PWM generation. Pulse width modulation, or PWM, is a technique used to control the amount of power delivered to an electrical device by rapidly switching the power supply on and off. Instead of providing a continuous analog voltage, PWM delivers a digital signal that alternates between on, high, and off, low states. The key parameter is the duty cycle. By adjusting the duty cycle, you effectively control the average voltage and power supplied to the load. PWM is an efficient, precise control mechanism and widely used in dimmers, battery management, robotics, motor speed control, and industrial automation. EV charging stations use PWM. EV speed control and management, audio amplifier and speaker systems, brushed and brushless motor speed control, household LED light dimmers, and fan speed circuits are common example of PWM. So what is PWM? Consider the given challenge. We have to control the brightness of LED. It is connected as per the diagram using an NPN transistor's collector terminal to a power source. The bias resistors have been omitted for simplicity. The input to the transistor's base is driven by a digital waveform. This digital waveform, which serves as input control signal, has frequency and amplitude fixed. How would you go about controlling the LED brightness? The answer is duty cycle of waveform. Duty cycle is defined by the relative on time in a single cycle of digital waveform. Imagine each cycle comprised of 100 units. If the logic on time on is 50 units, then the duty cycle is 50%. If the on time is 75 units, the duty cycle is 75%, and so on. Duty cycle is defined by the percentage of high logic time relative to the total cycle time. If the duty cycle is 100%, it means that the signal is on all the time. I have simulated a 50% duty cycle driving a LED. One end of LED is connected to the collector of an NPN transistor and other is tied to DC voltage. Transistor base is driven by the input digital waveform. For clarity, the bias resistors have been omitted from diagram. The cycle time of waveform is 2 seconds. The frequency is 0.5 Hz. The LED is on for 1 second and off for 1 second. Hence, duty cycle is 50%. This is a slightly different use case. Duty cycle in this case is 75%, which means LED is on for 1.5 seconds and off for 0.5 seconds. The cycle time of waveform remains 2 seconds. The frequency is 0.5 Hz. Let's discuss the implementation of PWM-driven LEDs by Arduino Uno Project. I connected anodes of 2 LEDs to pin number 9 and cathodes to ground directly to the header of Arduino Uno. You may attach a current limiting resistor of 270 ohms, but it's optional as port pins are current limited anyway. The setup is as simple as it can be. Let's look into the source code step by step. First section is important as it is related to the PWM library installation and PWM pin selection. You can install AVR PWM by searching the same in the license manager for Arduino Wine.de. We are going to use pin 9, which uses 16-bit timer 1. Next section creates an object or instance of AVR PWM type, which shall be used for the rest of the code. We then define float variables frequency and duty cycle and initialize them. Remember, it is always the best practice to initialize your variables when defining. First 3 lines in setup are optional. They only describe and print information on Arduino's real debug port. Next line initializes the PWM instance by assigning it the required information, frequency, duty cycle, and pin to use. Here comes the interesting part. In the loop section for Arduino, I have declared a continuous while loop, which carries in its belly a for loop. The job of the for loop is to assign a new duty cycle every 1 second by increments of 10 and keep the frequency same. The idea is to generate a PWM on pin 9 starting from 0 and all the way to 100% by increments of 10%. I compiled and downloaded the source code to Arduino Uno and recorded the test run execution. You may notice that LED pair brightness is not fixed. it is changing according to the programmed parameters. It starts from 0 brightness or 0% duty cycle all the way to maximum or 100% duty cycle in 10 seconds with increment of 10% every second. The cycle continues forever. We now have proven that LED brightness can be controlled directly by Arduino Uno using a third-party PWM library. The source code is simple. An idea of diving LEDs directly is engaging. The Arduino PWM library is easy to use and can be deployed for various applications and small test projects. Hope you have enjoyed the video tutorial. Please leave comments if any questions and subscribe to channel for support.